to one and all. I'm your host, Dr. Ruby Gill, and I feel honored to welcome you all on the behalf of lovely professional university. So attendees, what do you think the essence of today's webinar? Well, I'm glad to share with much excitement that today our expert will deliver his expertise and make us learn about image processing for color and shape-based object detection using Python. I'm sure you are as excited as I am for today's learning process, so kindly allow me to introduce our experts. Professor Bhupinder Verma, Dean, Head of School of Electronics and Electrical Engineering, lovely professional university. An intellectual and skilled educational leader with an experience of more than 23 years as an academician and industrial as well. He has undertaken many industrial automation projects with corporates like Hero, Escher, and so on other renowned companies. He has been visiting faculty to the international universities like Wayne State University, Detroit, USA, United States of America, and Hiram College, Cleveland, Ohio, United States of America as well. His research interest lies in smart sensors, image processing, industrial automation, satellite design, and IoT. To his credit, he has published more than 30 research papers in national and international journals of repute, and he is the senior member of IEEE as well and lifetime member of Indian Science Congress Association. So sir, it's a privilege to have you on board with us today. Thank you so much for joining.
Thank you.
Furthermore, we have with us Dr. Bhavesh Kumar C. Dharmani, Associate Professor and Coordinator of Domain, Signal and Image Processing, School of Electronics and Electrical Engineering, lovely professional university. A dynamic professional with an experience of more than 16 years as an academician and in research as well. Also, he worked as a visiting scientist for more than 8 months at Interdisciplinary Statistical Research Unit, ISI, Kolkata. To his credit, he has 6 patents, more than 10 research publications in international and national journals. He has supervised and undertaken 6 PhD theses as well. So, sir, thank you so much for giving us your valuable time. Thank you so much for joining. Additionally, I would like to welcome our admission expert, Mr. Pankaj Vij, Assistant Director, Department of Tie-Ups, Division of Admissions, lovely professional university. With a master's degree in management, he has a keen interest in the area of training and development. He is having more than 20 years of experience in multiple domains, including teaching, training, and operations. He has occupied strategic positions in multiple organizations of repute, and attendees today, he'll give you an insight of eligibility fee and scholarship, which I'm sure will make you save a lot of money. And in addition to that, he'll also be discussing about the infrastructure part of the university. So thank you so much, sir, for joining us today. So with this, I welcome you all once again to the webinar and looking forward for a great interactive session. So over to you, sir, for the content of the day.
Okay, thank you, Ruby, for the nice introduction, and I welcome all the inspiring young minds and those who are motivated to learn how we can implement image processing using Python. Okay, so I hope you have some basics, or maybe you have started with at least any programming language you had open up with, and maybe some of you have already started with Python. Okay, so I will not be going to introduce you what is Python or the basic literals of the Python. Okay, but we will start directly with how we can implement image processing, simple image processing using Python. Okay, and specifically there are multiple libraries for the same, but what I will be using for the same, that is actually an OpenCV as our library. Okay, so with that, let us start with. Okay, so we find there are images everywhere nowadays. Okay, you know, you go to the social media, digital profiles, everywhere you find lot many images, okay, lot many video apps or image filtering apps, okay. So many smart faces or maybe beautification possible at simple apps, mobile apps. So the thing is how we can do it or how that could be done. So let's start to get some glimpses on how we can achieve this thing, right? Because I hope by you have decided the engineering career, and by deciding that career, you are not just going to be a technology user, but a technology creator, right? So with that hope, let's proceed further. So what's an image basically? Okay, so see, image, ultimately you understand one thing. What computer can process is the numbers. Okay. Ultimately, computers can process only the numbers. Okay. So whatever, everything, whatever the things you want to process through computers, okay, smartly, that has to be first converted into numbers. Okay. That's the basic idea. Okay. So how we convert basically image as a number. Okay. How we convert image in terms of number, that is a basic query. Okay, so the simple solution is what we do basically, as you can see here, this is a complete image that has been divided into small grids. Actually, you can see there are vertical lines and there are horizontal lines. Okay, so they are completely going. Okay, so that way the whole image that has been divided into very small sections, these are small square sections, you can find them, right? So these are square sections. Okay, now what we do basically to represent the complete image, okay, what we do for every this sort of square region, this is a square region, one square region, right? We represent it through one particular, sorry, yeah, through one particular, we call it a pixel. We represent it, the image, the color of that we represent through one number. Okay, we represent it through one number. Okay, so that's how what we do actually. This is a simple image. Now what we have done, we have divided this image into number of sub, that is sub areas. Okay, and for every corresponding area we will have some particular numbers here. Okay, so let's say this is an image. Okay, this is an image, it is completely, it's a binary image. Binary image means what? It is having only two colors, one is black, another is white. Okay, so what we do, see, usually zero, that is nothing, nothingness we represent through black, right? And everything, you know, white color is made up of all the seven colors, right? So we say that is nothing means black, that is zero represents the black, and one, that is full color, that represents white. Okay, so this is a binary image. You can see on this left pen, that is an image Mickey Mouse. Okay, but you can see how it looks like. That is, say, this is the picture window that has been divided into smaller windows, smaller sections, grid. Okay, and each grid that is colored either using black or white. Okay, and corresponding to that you can find there is, it is converted into equivalent numbers. You can see wherever there was white color, white means everything, that means 1. Okay, black, no color, that means it is 0. And that's how you can find here the same picture converted into a two-dimensional array. It is a two-dimensional matrix, or you can say two-dimensional array, right? You have studied matrices possibly, so you can see. So the simple logic how we convert the image in terms of the numbers. Let's say here we have divided the image into 35 rows and 35 columns. Okay, there are 35 rows and 35 columns, and accordingly the image size that becomes 35 cross 35. Okay, so 35 cross 35, that many number of pixels we are using to represent this particular image, right? Now let's say, let's move further, because we have moved further since the binary image. We are not using binary image. Let's say go one step ahead, that is through grayscale image. Grayscale image is what? they are still black and white. Okay, they are still black and white, but at least you have some shades of gray. Okay, so again what we'll have, see 0 0 no color, that means black, FF that is white, and whatever the in between range, that is 0 0 to FF, that shows a range varying from black to white. Okay, more towards black it is more towards 0, more towards white it is towards FFH, right? So that way you can see, just this is an image and black and white image, just a section of it that I have shown here. This is black and white. So simply you can see this sort of gray, it is 170, it is pure white, sort of near white, and that is 235. Okay. Why FFH? That is also a logic, you know. Your computer's minimum works on 8-bit numbers, right? 8-bit numbers, that is binary 8-bit numbers, right? So binary 8 bits, in the hexadecimal it will be FF, and in, you can say, decimal it will be ranging from 0 to 255 maximum number, right? So in binary this will be ranging from, you can say, maximum ranging from 0 to 256. Okay. So anyway, so perfectly black wherever you find, that is going to be 0, white that will be, you can say, there is 255, in between there are shades. Okay, fine. So basically just imagine now that what is the importance of pixel. Okay, so you know you are using mobile cameras, right? Mobile phones which are having nowadays very good. So what will be the number of pixels in your camera? Your study that is having actually mobile camera that is 1 megapixel, 2 megapixel. Nowadays that is actually 5 megapixel. Is also quite common. Many mobile phone that gives up to 12 megapixel. Okay, so you can understand what happens. What is the meaning of pixel? Basically, this is your picture frame, basically, right? It is a square frame. Let's say this is your square frame, and that frame you are dividing into how many smaller sections, right? As the sections are more nearer, right, the area which you are representing for 1 pixel, if that grid area that is smaller, you get better resolution. Okay, or you get more sort of color variations or color intensities, and that's how the clarity of the picture that will be better. Okay, so that's why you can find that is when you are using mobile, you always try to get a mobile phone with a better number of pixels. Okay, of course there is few more things you might have seen that sometimes there is iPhone with an equivalent megapixel. Okay, that gives quite high clarity than other phones, right? But anyway, so the next is basically what are the next step, that is, because we are not even in the world where there were grayscale image, we are in the world where we are using color images. Okay, color images. So when you say color images, okay, so there is one logic, that is any color, you know, that is made up of 3 basic colors. Okay, 3 basic colors, and here we select 3 basic colors as red, okay, green and blue. Okay, it could be RYB or but generally in a image processing area it is actually red, green and blue, right? Red, green and blue. Okay, so now what happens? Okay, say let's say this is a specific image that has been divided into number of grids. Let's say it is 5 rows and there are 10 columns. Okay, the width has been divided into 10 areas, 10 vertical columns, and the height that has been divided into, you can say, 5 rows. Okay, so each of this area that represents some color. Okay, that represents some color, but we have seen that is color has to be represented in terms of number. If you use only one number, that will be a grayscale, right? So that could represent from variation in between black and white, right? So when we want the color image, we use 3 pixels per area, 3 numbers per area. Okay, per this area we represent 3 numbers basically. Okay, and what that numbers represent? One represents the combination of what is the intensity of red color, what is the intensity of green color, what is the intensity of blue color. Okay, Again, that intensities would be varying between 0, 0 to FFH. The same logic, 0, 0, that means suppose in the red channel, there is 0, 0, okay, that is 0, 0. That means what? 0 means there is no red color existing, and if it is 255, okay, it is going to be, let's say, if it is 255, let's say it is going to be full red color, okay. So that way the color per pixel, that is how it is. So and each pixel that will be now through 3 gaps, okay. So you'll find that for the same image, you will require how many pixels, you require how many data bytes or numbers you have, that is 5 rows, 10 columns, and you see now these are three channels: red channel, green channel, and the blue channel, okay, RGB. So there are three channels. So this is number of rows, number of columns, and number of channels. So this many number of bits, that is bytes, that is 8-bit numbers, are required to store for one particular pixel, okay. So now you know understand the importance of the memory, right? So how much memory it will require, okay, how much memory it will require, right? So depending upon, if you increase the pixel size, this is image representation. Let's say the same image I represent in terms of binary. This is a grayscale image, and this is a color image, okay. Binary, grayscale, and color. This is actually a very famous Lena image. Actually, it has got too much importance and significance in the image processing research. So since quite early age, this is being used because it has some specific characteristic, not just because it is a model face. There are a lot many good characteristics for image processing research. It has got some Gaussian curve here, Gaussian curve here, right? This has got edges actually, so that somehow it is characteristics are good. It is also having a face, so that way it is having. So you have basically, you can see that is you have this type of representation for images, right? So now you understand that how specifically the images are represented in terms of numbers, right? Now let's move to the Python, okay. See, in Python there are not only one library, there are multiple libraries which you can use. One is actually Python imaging library, that is PIL. Basically it was with older library, but still it is used. OpenCV, that is more popular and a relatively newer one, and so it is highly used for image processing purposes, right? Now, NumPy, SciPy libraries, they are for basically array manipulation. NumPy is for array manipulation, SciPy is for some scientific calculations, right? So these things are basically required because your images you are representing in terms of numbers or arrays, maybe one-dimensional array, two-dimensional array, or if it is color image, that is going to be three-dimensional. If you say now videos, color video, okay, so color video will be now four-dimensional, because video is what, basically just the image is stacked together and flowing with respect to time, moving with respect to time, right? So that's how videos will be actually four-dimensional arrays, okay, matrices, okay. So scikit is actually for that is again for there are many versions of scikit. Even scikit that is for machine learning as well as other scientific operations. Scikit learn is for machine learning, okay, because it is also related with just one more instruction, that is the how we can install. Because when you install Python, either through the command window or maybe through Anaconda installs Jupyter notebook and many other processing, but it is the libraries you are supposed to manually install afterwards. The basic Python do not come with OpenCV, right? So you are supposed to install it, okay. Now how you can install it, I'll show you just. But it is simply, what you can do is you just need to, let's say, use this command pip install OpenCV Python, okay. Pip install OpenCV Python. If you are using, that is this pip command also should have been install in your that is when you use Anaconda. Okay, you can also run this direct on your Jupyter notebook, right? So that way is also possible. Okay, so now onwards, let me switch over to the Jupyter screen, I think. So that will be better. I will be showing you some of the basic processings in Python, right? So let me switch over to the Jupyter screen. I have already made it open, right? So that I can directly start working on it, right? I have, okay, let me open a new library, just new file, that is, okay. I have installed Python 3, so it is opening Python 3. But say, uh, let me now give this a name, that is image demo, right? So let's say, okay, say where I have installed this. Actually, this is my, I have Mac machine, and I do have a Spywork is my and basic image processing, that is my folder. Okay, in that folder I do have already some images there for basic image processing. So I am there. Okay, so you need to, if you are having, for simplicity, if you are working parallelly, what you can do is keep some image in the folder where you are opening your Jupyter notebook, right? Let's say my Jupyter notebook, that is by default opening in documents. I am opening through it, that is Spywork image processing, and here I have opened my new notebook, right? So image demo, right? So let's say how we can do first of all, right? Okay, one more thing I will show you, that is because even I before demonstrating this, yes, no, I think I have closed that file. What was the file name? Yeah, maybe yesterday I actually ran that file. Okay, yeah. So even for me, this was actually my I had to reinstall somehow for the reason. So before few days I had reinstalled my Anaconda, and it was not having OpenCV. So when you run it, what it does actually, it first downloads the module, right? OpenCV Python, it first downloads, right? So first of all, see, I'm discussing the challenge is when you install this library. Okay, so when you see what happens, basically when you use this command, it is going to download it, right? So first thing is you should be connected with a good internet speed, right? Wi-Fi should be proper. Okay, and then you get, so first it downloads, and after downloading it is going to install it. Sometimes student face the answer, that is connection is weaker, or maybe sometimes your connection is open, okay, but the server from where the it is installed in the Python, that server is bit occupied, and that way it is taking some time. Don't worry about it. It will take some time for downloading, and then after it is going to get installed. Okay, yes, yesterday I had to do this. Okay, so fine, that's okay. Okay, so now let's say what we can do. So any library is not default available in Python. Okay, so you have to import it, right? So import, let's say what I will need, I will be requiring NumPy, and I will alias is NP. What is it basically? NumPy is a library which is giving me basic array processing capacities. Okay, so I'm importing NumPy and aliasing. I will giving a name, other name. I am aliasing it as NP. So I will, in my file, I will call it as NP. Wherever I NP, it will refer that class from that function from NumPy, right? Another I will require, that is import matplotlib. Okay, this is to display the image. This is a better idea, even though OpenCV is having it, but I will use this thing because it has got less confusion. Matplotlib.pyplot. Okay, this is library, one specific module pyplot of matplotlib I need, and I will alias it as using it as plt in my module, right? Also I am supposed to import CV2. CV2 is actually OpenCV latest version. Okay, so this is my import. Yes, so it has run. So because they are already installed, it will run. If it is showing, that is, if it is not installed, you can use pip command to install it, right? Now let's say I have many files in my folder which are image files. So let me open some file. Okay, so what I can do, let's say I'm reading an image file into a variable image. Okay, for that I have a command I am read, that is image reading, that is I am read command is there in cv2, right? cv2 library name, and in that there is I am read is a function name, right? So I am read which file name I want to read. Let's say I am reading, that is baboon.jpg, right? I have a baboon file. Okay, let me show you how it looks like. Yes, this is baboon gray. Okay, okay, baboon color, its name is baboon color, right? So baboon color is this file. Okay, so I'll open this particular file, baboon underscore color, right? In case this file is not there in your same folder where you are working, I'm working in my this file. You can see my file name is image underscore demo, right? If image underscore demo is also in the same folder, I need not to provide the path, otherwise I need to provide a complete path. Okay, understand this, I need to provide a complete path. Okay, so when I'm reading the image, what it does, it is going to read it in terms of an array number image. Okay, so let me check what is going to be the image, let's say shape. Okay, so let me run it, right? So what is the image size? Actually it is image is 512 cross 512. It is color image, so there are three particular channels are there. Okay, RGB, right? And now let me show you that is how it will look like, right? See, the indexing inlet starts from 0 to vaccine. So just I will show you 0 to 10, and this is, there are three channels. I will just show you the channel 0, right? Okay, fine. Okay, so you can see this is how I have shown first 10, 0 to 10. This is end plus one number, so it will show 0th column 9, 0th row, 9th row, 0th row to 9th row, and again 0th row to 9th column, and then 0th channel, right? So that's how it is showing you these numbers. You can find they are always between 00 to 255. Okay, always they are going to be between 00 to 255. But see, we are not satisfied with these numbers, we want to visualize this image. Okay, so let me show now plt what I am using. matplotlib.py applet functionality I am using. There is a function I am show image show. Okay, now image is going to show what? It is going to show the numpy array, that is image. It is not going to directly show you this image. You need to convert the images into numbers, and then it can display the numbers only, right? So that's how plt.imshow and image img, right? So you can see here, yeah, this is the image. Okay, but now some of you have noticed that this was the original image, right? Where you can see the nose is red, and if I find this is blue. How come this is show, right? So this is one of the that is idea actually. That is reason is actually OpenCV. This specific characteristics of CV2. Whenever I am reading OpenCV, actually what it does, usual, see, in the outer world or wherever normally we go, RGB format is used, right? That is 0 channel for R, first channel for G, and 2 channel for B. But in case of OpenCV, it is going to be BGR. Okay, BGR. So what happens basically? It is going to read red as blue and blue as red. Okay, and that's how you can find the whole confusion. Actually, it is not confusion. It is for specific purpose basically. But somehow this is somewhat a different nomenclature than this. Yes. But now, if you want to see the original image, how you can? Yes, we can do that, right? So we can do through color conversion facilities. Okay, color conversion facilities. Okay, so where are that color conversion facilities? Okay, I can have, let's say I am creating image in terms of RGB. What I do, I will be using a function cv2 dot convert color. Sorry, CVT convert color, that is my functionality. I will use first image, that is image, and in what, see, this is CVT color is actually color, convert your color. Okay, now in what color you want to convert? So I am here, I am giving a functionality that it is a symbol, that is what color I want to color, that is CVT color underscore, this is going to be BGR, which is the usual format for OpenCV to RGB, right? The word nomenclatures are also very much common, and then I will use the same functionality, that is PLT dot IMShow. Okay, and now I'll be showing just image in terms of RGB, right? So that's how, if I run it, it is going to be, that's why you can see now it matches the original image. Okay, so it matches the original image, right? So this is the how you can read and display image. Okay, now what we can, how we can process it, or we can assess it. Okay, first till is you can resize it, like suppose image 1, that is if I resize it, that is I will use the function resize, because many times you can see, okay, resize, which image you want to resize, image RGB I want to resize. Okay, and to what, see, when you are resizing, you need to provide the argument, that is what size you want to provide, right? Let's say I want to convert the 5 cross, that is, it was basically 512 cross 512, right? So I want to convert this into 64 by 64, right? 64 by 64 cross 64 image, right? So, and now let's say I'll be using the command, that is plt dot imshow in terms of that is img1. Okay, so resizing this thing, right? You can say here, right? So original image, that was 512 cross 512. See, you can see there's a blurred, right? It is quite blurred. You can see, even you can make it, let's say 128 cross 128. Will not even notice the difference. Okay, will not even notice the that much, but still there is a difference, and you can see the change in resolution. Okay, but perceptually, if you go less than this, if you just go by 8 cross 8, suppose, that would also be needed sometimes. You can see it is just a square blocks. Okay, so currently let us go for 64 cross 64, right? So that is going to be resizing it. Okay, let's flip the original image, let's flip the image. Okay, so let's say I will say image I have fun to this image 0, that is I am going to use functionality cv2 dot that is flip. Okay, cv2 dot flip, which image, that is image RGB, and I am flipping it. I can flip in 3 ways actually. Flip horizontally, okay, and then let's say plt dot imshow, and this is img0. Okay, so let's say, let's run this. Yes, you can see this. I just flip it. Okay, it would be interesting to note down what basically happens, or you can say, if I go for here 1, what happens basically. You can see it will flip vertically. Okay, it will flip vertically. Okay, see here you can see this was the baboon, that is here it is find it more darker region. The darker region has now switched over to this part. If I say, if I want both flipping horizontally as well as this, I'll use -1. Okay, and that is happening both way actually, right? Let's say, let me show you some interesting thing here, that is if I show you what happens basically. What happens basically, this is image, let me call it 2, and let me have simply in terms of 8 cross 8, and I will display simply img2, right? So whole number set. Okay, so let's say if I show you, okay, let me show this only one channel. So any channel from the 0th one and channel 0 I am selecting. Okay, so these are some values, 100 values. Okay, so it is now converted into 8 cross 8, right? So that 8 cross 8 images, so this is a complete image which is this representing the baboon image, and this is simply 0th channel I have shown. But you can see if I now flip over it, image 20, okay, that is now say cv2 dot flip, right? And that is which image I will be flipping. I will be flipping image 2 in terms of 0, and let me check what is going to be image 2 0, right? The data of it. Oh, sorry, again I did mistake. That is only I will see the 0 channel, right? Yes, and you can see what happened. The first row, okay, it has flipped the rows. The first row become the last 156 166 156 100, and the last row, that is 156 120 180, that has become. So it has switch over, that is 159 190 195 159, right? So it has flip over horizontally all the pixels. See, understand, so what does it mean? Basically we are perceptually looking at the image. If you see now, I am sure that is plt. Okay, I have shown it actually, but if you see the image perceptually, it will be looking the horizontally flipped, right? Perceptually this was different, but numerically back end side what I am doing, I am doing simple mathematical logic, that is I am reversing the numbers. Okay, rows, the 0th row become the last row, and 0 same way if I go for the flipping by 1, okay, what will happen? It is going to be flipping vertically, that is the last column 126 162, that become the first column, and the first column 156 159, that is going to be flipping that way. And when I do both the things, it overrides both the operations, right? It is going to have both the operations. You can see 156 159 195, right? So this is the first column that has become first row, but in a reverse manner, right? 156 1, that way you can see the last row, that is last column, that has become. So everywhere you will find that is say 126 once is that has been flipped, and from the last it has become the last. Okay, so that way I think this is a simple flipping operation and the resize operation. Okay, flipping operation and the resize operation. Now simply I'll just demonstrate you the towards the, that is the shape, how you detect the shape. So I think till now you understood some of the basic operations, that is how you do. Basically you are working with number. Just let me give you one more demonstration. That is if I go for let's say image RGB as, let me convert. Okay, image 3 I am doing FF, that is sorry 255 minus uh, okay, let me take first convert into grayscale image, right? So let me check this, that will be better demonstration. So I'm using the copy pasting of the code. Yes, let's say I'll copy this thing, right? And I am now converting color from BGR to gray. Okay, and this is my image gray. Okay, this is I am displaying image gray, right? But then when you are displaying image gray, I have to select here mapping as gray, otherwise it will still try to show it as a color image. You can see this is a gray image. Okay, now what I will do, just understand, this is now image 3, that is equal to 255 minus img gray. Okay, see I'm getting what I want to get the negative of this image. Negative is what, you know, if you have seen the old camera films, negative, what they do basically, the black portion they are reflected as white, white portions are reflected as black. The same thing here happens. This is the color image. I will just show, and this is plt.imshow, and this is img3, right? and you can find, oh sorry, this may, yeah, this is how it will look if you are, because it is trying to conceive that it is still a color image, right? So oh, what happened, I did some mistake. Anyway, let me check first. Anyway, so this is how I
Dr.
can,
Bhavesh, I think
yeah,
spelling of gray is wrong.
sure. Yes sir, you can proceed, I'll verify this.
No,
So
the spelling of gray is wrong. I suppose
oh
due to
yeah,
that.
yeah, right. Yes. Okay, you can see here now. So it is just a negative of what we were looking at, right? Everything which is white is black now. Okay. Anyway, sir, I think I will demonstrate one project, but maybe it will be afterwards. I think you have a lecture at 11, so maybe first you can take over.
No, I don't have lecture today. Don't
Acha,
worry.
okay. So now I will, so that's how basically I was showing you that basically what is image processing. The backend is actually, arrays are there, okay, the numbers are there, and you are working with simple mathematical operations on that number. That's how it is image processing, okay. So, and many times you means when you're working with this sort of libraries, you need not to worry, means sometimes you can even just understand it virtually, and how to implement the actual mathematical operation you may not be even aware of that things, okay. So to demonstrate it, I'll come to a shape detection task, okay. So I have specifically, this is, let's say again I have done that is, I will just demonstrate it, right. I have called, imported the library modules which are required. I am reading one shapes.jpg, that is I am having in my folder shapes.jpg, and that is just to again to convert from BGR to RGB. I am using cp2 dot convert color image and cp2 dot this. Okay, I am giving plot some writer that is, okay. Let's see. Let me run this. Okay, and you can see this is the image. Basically, this was the image, right? Okay, now I want to detect the shapes. What are these shapes? Okay, so for this particular, when I am interested only in detecting shapes, see, colors do not matter. Agree? So colors do not matter. So don't unnecessarily let me try to, because when I'm working with the color, I am actually using three-dimensional arrays. Okay, three channels. Okay, so let me first convert into grayscale, and then we know even to detect the shapes, I need not to work even grayscale image. I can simply work on binary image. Okay, I can simply work on binary image. So let us first convert this into grayscale image. So that is, again we had already looked at, that is color to from BGR to gray. Okay, so I am converting the image, the same image, from BGR to gray, and this is my grayscale image. You can see the color. Again I will say, as I said, that is I did not even to require to work in gray. So just understand that, understand the color space. That is, many times looking at your functionality, you may decide to choose either in the binary images, or maybe grayscale images, or maybe color images. I think for the shape detection task, it is better to convert this into simply a binary image. Okay, now but binary image conversion, that is one way to do it using thresholding. Thresholding is what is, I am applying some simple logic. Once again, this image, wherever there are white shades, that means which color? White means full. Okay, full, that is 255 value. Completely black, that is it's going to be 0, right? So you have some gray shades. I just will convert them, all of the gray shades, into black. Okay, so that the background is going to be white and the shapes are completely in the black. So that's what I will do. Okay, now how I can do? So first let me explain you, that is what is this img gray, right? Image gray I can show you here. You can see these are numbers simply, and but it is just showing you some of the values it is giving you, I can see the specific values also, okay, and but you can see the white part is 255, and that's all. So what I've done, I had to decide some threshold, right? So what are the threshold? For that threshold, after that threshold, it is going to convert in the whatever way you want basically. So I'm using the functionality like say I'm using cv2 dot threshold, okay, and I'm using image gray. How this functionality is, let me show you. That is, I will just show you. That is, let's say that is OpenCV, and I have a function that is for that is thresholding function. That is cv2 dot threshold, or you can simply search on these things. Why I'm showing you that is how, because say the faculty's responsibility not just to bind up to what we teach, but I'm leading you to the open-ended journey. There are lot many resources already available, okay. So just I will open up that. You can see lot many. This is docx OpenCV. That is the basic. OpenCV itself is provided the documentation itself is the best material, the original material, right? You can find there many open materials, like suppose gigs for gigs is again a very good site with, it is going to show examples. Learn OpenCV, that is also a good site. There are many more sites will be open, they will be, but OpenCV documentation, that is, you can see it is going to be the most original documentation, right? It is going to explain you all the things in detail, okay. So like simple thresholding, the function, how many functions are available for thresholding. So CV threshold is the function. Let's say I will open in the next page, I'll show you what are the related that is constants and variable. Even it will provide you a demonstration how to do this, okay. So there are multiple things possible, that is, you can say, let me come to this. Yes, so this is how you use threshold function. It is requiring source as an input array, destination is output array, and this is how you should do it. This is the demonstration, right? cv2 dot threshold, source is a one argument, thresh, that is the another argument, second argument should be whatever threshold. What does it mean? We'll look at it. And then maximum value, type, destination. So this is how you are looking at it. And what does that mean? Source means input array, right? Input image array, right? Destination is the output array of the same size, right? And number of channels, everything. If it is grayscale, it will be output will be gray. If it is color, it is going to be color, right? Threshold value, okay. Threshold value, and threshold value, what it is going to be, that you can threshold value that could be that is going to be, there are lower thresholds and the higher threshold value, that is going to be lower threshold and the higher threshold value. Maxwell, that is going to be maximum value to use the threshold. Whether this is threshold binary or threshold, is actually a flag bit actually. What this flag bit denote, that is threshold, you can check it, that is threshold binary. How it works, that is, if it is going to, basically I will explain you the whole thing, all the functions have been shown here. What it will check, if it is greater than the threshold value, okay, it will be going to represent as a maximum value, otherwise it is going to be zero, right? So what we need basically is this, that we want to have the whatever the grayscale image, gray parts, okay, that we want to convert into black, okay. So whatever the value I would select, that is I am saying here, that is the default threshold is thresh underscore binary. I want to convert in the binary image. Other options are there, right? Other options are binary inverted, right? Instead of black, you can convert into gray, or sorry, white, okay. Truncated, that is just remove some of those are the output. Binary will be this way, inverted binary will be black part will be white and white will be. So suppose this is the original image, threshold is set somewhere in between. You can see here the left part is black, right part is white. Other way, it is in black part becomes white, the white part becomes black, okay. Truncated means the higher values will be simply truncated, okay. and then towards 0, that is towards black color convert into, towards white color convert into. That's how the interpretation would be, right? So here I am, what I am doing, I am converting image gray. The lower threshold I have basically choose many alternatives, and from that I will just show you. From first I will get the result and then I will show 220, 255. This is a lower threshold. It is saying what? Between, if the pixel values, okay, are between this two, okay, that is, if, how it is working, I have shown you here. That is, if the pixel value is greater than threshold, okay, then convert into the maximum value, otherwise convert it into 0. Okay, if the pixel values are between 222 to 255, convert them into pure white, otherwise convert them into 0. So what I am saying, whatever the black, the maximum gray value is my around 220 basically. So it's why, that's how it is. I will show you with some other images. Let's say here I am changing it to simply 50. Okay, let's see how it represents. So all the values between 50 to 255 will be white, and remaining 0 to 50, that is going to be completely black. Okay, so you can see all of them have been completely black skin, right? Let me show you. The values are bit higher than within this range. Okay, if the values are high within this range, it is going to be converted to black. Okay, you can see 100 to 255. This darker regions, this part, this four images, you can see they're quite darker. So they are between, there the values, because see 0 means no color, right? So these are between 0 to 99 values are there, and that's why they have been shown here. But remaining shapes, they are gray, and the gray value are between 100 to 255. 255 indicates pure white, and that will be converted into maximum value is 255, that is pure white, right? So that will be converted into this. So that's how I have shown 255, and you can see some more colors. Find say 220, 200. Okay, find some of the test part is left, and that's why I have set it to somewhere 220. Okay, so this may come through some experience or some experimentation will be required. So this is how it is converting into color images. Okay, and then after, what you need is, what is the shape? Okay, so there is a functionality, find contours. Okay, contours means what? It is identifying the close curves in your image. How many close curves are there? It is going to provide the end pixel values of this. Okay, boundary pixel values of this. For example, I am converting, this is going to two outputs, cvt.find converse, and what I will be giving, threshold. This is returning a threshold image, right? Thresholded image that I am showing. Okay, and that I am giving input here. As I have shown here, fine contours, I have somewhere already opened the fine contour, draw contour this is. But anyway, I'll just demonstrated you, that is, you can see, look at that values. Okay, and this is actually the flag, how you want to return. Okay, contour values, how you want to return. Okay, that is what the flag indicates. I have shown it to be simply connected, and that's how it is giving me contours and hierarchy. These are the two outcomes. And contours, if I run this, it is giving me this. Okay, so you can see, if there are, say in your image, in our image, there were basically this is first one is the rectangle. Okay, there are four corners. So you'll find here there are four corners will be there. Okay, yes, say 0 0 0 4, these are the four corners. The first element, that is contour, closed surface, that is actually having four corners. Okay, so that's how it is defining. Somewhere if it is triangle, it will be 3. Somewhere it is a pentagon, it will be 5. If it is octagon, it is 8. Okay, circle, it is going to be more than 10, right? So circle, it is going to be more than. So contour identifies, like suppose I will show you, this is more than 10, right? So it is showing you somewhere, yes, this is 3 only, so that is for triangle. So just it is giving you specific locations where it is. Okay, now I want to demonstrate it. I will be providing you box boundaries. Okay, so how I have plotted that, actually just I will go through it. that is contours is an array, right? So I'm providing a for loop for every contour identified in this particular. Okay, what first I will find, what there is a functionality approximate polygon, that is a polygon. Okay, what is the polygon approximately? You know, here I am having in this image almost an exact shapes, but practically you may have somewhat approximation. Okay, so that approximations also could be identified either as a rectangle or with a specific polynomial polygon face. Okay, DP is actually name of the algorithm basically. I think this one is for that. Yeah, this is put text and draw colors. Okay. Anyway, yeah, approximate DP. DP polygon DP. DP is Douglas Hooker algorithm basically. For that it is okay, and it is going to give you the approximate shape. Okay, and there where it is going to provide you approximate shape, again it will be boundaries, the corner points of that shape. Okay, and here you can provide the second argument you can provide, that is how much variation approximation you allow, epsilon value. So there I have put that is 0.01 into the length of the arc, whatever the length of the arc, how much variation in the shapes you can allow. If this is in the perfect instead of rectangular, if it is somewhat curvy, whether you should allow it, how much pixel variations you should allow it. Okay, so that I am specifying here, that is you can based on the length of the arc 1% of variation I am allowing. Okay, 0.01, that is 1% of variation I am allowing to whatever the contour shape. Okay, so that's how I'm shaping. That is it is giving me approximate. Again it is providing you pixel means corners of the boundary box contours, and then I am drawing using that approximate curves. Okay, I am overriding the original image. IMG was my original image, right? IMG was my original. I'm on that image, I am drawing my what I'm drawing the contours. Okay, with at what level, which pixel values, whatever the contour locations there I am providing. Okay, 00 is outer side only. 000, this is indicating the color, black color, red color, which color boundary I can select. I can select any color boundary here. Okay, and phi is the width, what should be the line width. Okay, width I have selected phi, that is bit lengthier, but it is at least demonstrable, right? And then this is the pixel variation I have allowed, right? Now it is checking if the length of the approach, that is if I have said that is if this array has 3 corners, then it is triangle, right? So it is lead give put text triangle, where it is whatever this contour locations and approximated value at that location. Okay, at that coordinate values you provide the triangle location, and then this is the font selection, this is this what is the size of the fonts, and this again the color of the fonts. Okay, so that way basically for length, then it is either I'm checking the aspect ratio, because it could be if it is 4 sides, it could be either a square or rectangular. Okay, so that way I'm checking the aspect ratio. If it is greater than equal to 0.9, it is almost a square, otherwise it is going to be rectangular. If it is 5, it is pentagon. If it is 10, I am saying it is star, otherwise I will name it as a circle. Okay, so let me run this, and this is how it has put the red boundaries, because what I did, I changed it to 255. If it would be 0, 0, 0, 0 is black. Okay, so that's how I can detect the shapes basically. Fine, so I hope can enjoyed the things, and now you can work upon further. Okay, don't hesitate to use open resources. Python is an open source language. Any library you use, OpenCV or any other, there is always a documentation available. If you don't know anything, go for OpenCV tutorial section, right? And that is going to provide you, if this is a Python original material, right? The original documentation which is going to provide you OpenCV tutorials, introduction you want, or some detail you want, what you want basically, how you want 3D pictures and deep neural network applications, and everything is there. You can go for introduction to OpenCV. There are many steps. Okay, how to install OpenCV, guidelines for that, right? Everything is there. Okay, so just go for that, and you can apply the that is getting started with images, and there you can start with your, again the codes are in also C++ as well as Python. You can start reading and executing. So that's going to be a nice tutorial. Okay, so but now I think I have enabled you with the basic understanding of how or what basically image is, and how just by processing with the numbers, mathematical operations on the back end with the numbers, you can generate it, right? Just apply your logical mind, right? Suppose here I have said shape detection. Now you can go for, if I have a coin image, whether you can identify whether it is a coin or not. Yes, you can apply the logic, that is, this is a coin image. You can say what is a coin, if it is a coin, if it is a circle, what is the diameter, find out it. Accordingly you can decide whether it is a 5 paisa coin, 10 paisa coin, 1 rupee coin, or 10 rupee coin, right? So that could be simple application to start with, right? And you can go for further, and I think this is the first step to enter into the image processing. And I hope you enjoyed. Thank you very much for sharing the opportunity to me to be with you and to share something, right? Thank you very much. So over to you, sir. Thank you.
Yeah, thank you, Dr. Bhavesh. I hope,
Yeah.
guys, you have dived deep into the mathematics and how the matrices are used in image processing. And I will take you to the real-time applications of this image processing. I hope you all know you carry the smartphones these days, and you always talk about how many megapixels are there for your camera, and you get better and better pictures in case it is the smart camera with 8 megapixels, 16 megapixels, like that. So it is all about image processing, and the digital categorization of the images is done there. And we at School of Electronics and Electrical Engineering, we talk about making the engineers to design smart systems. So we always say smart is the phone, smart is the camera now, smart cities, smart grids are coming up. So how do we make them smarter? And one of the key aspects of making them smarter is using the image processing technique to provide vision to the devices. Okay, so guys, you must have noticed, maybe if you go to the ATM of a bank, you see a camera being installed over there, right? That camera keeps on taking the images of the persons who operate the ATM, but it silently keeps on recording whatever is happening. So think of a situation when the camera can alert somebody that this person is doing abnormal kind of things in the ATM. Maybe he's trying to steal the cash, or maybe trying to take away the cash chester of the machine. Or sometimes you have these kind of news also that the whole ATM has been taken by the thieves, right? Think of those kind of smart systems where the camera is watching you and making alerts to the banking authorities of the security agencies that something is going to happen, because the camera is seeing something abnormal being done by the person who is the user. Think about this. And when you think about this, the technology to be used to make that camera smart camera is the image processing. And once you apply the image processing, and it becomes what? Computer vision. The computer system can see the things the way we see as humans. We see the things happening and take decisions accordingly. And seeing the things is one of the best senses the Almighty God has given to us. So if we can give this capability to the systems also, to the cameras also, then it is categorized as smart system or smart camera. So learn about these things, and this is what is the beauty of the technology. So I sum up with these remarks, and I hope you are quite motivated to go into these details and make systems for the society at large. Okay, so thank you very much for being with us, and now I hand it over to the admission coordinator to take it further. Thank you.
Thank you so much, sir, for sharing your vision with the attendees. And thank you so much, Dr. Bhavesh Kumar, sir, for intensifying and magnifying the knowledge of our attendees. And after this, I believe attendees will be proficient in Python application and will sparkle with this gain expertise. So thank you so much, sir. So before we move on to our admission expert, we have few queries from the attendees. So with your permission, we'll take up those queries, sir.
Sure, sure, sure. I'm there.
All right, sir. So, sir, there's a query from Gur Amrit Singh. He wants to know that in which semester or in which year he learned about this image processing.
See, we will teach you the basics first in the first year, and then after knowing the digitalization of the systems in the first year, you can opt for certain courses which are actually delivered from third semester onwards, that you can specialize in any area, and 5-6 courses in tandem, one after the other, they make you lot of expertise you can have through that. So in the second year, you can hope certain things coming to you.
Thank you so much, sir. So, sir, we'll take up another query that is from Tenzin. Sir, he wants to know that will there be any other software we'll be working on during the course duration? Or if we are chosen this specialization image processing, so we'll work on only this, or we'll be able to learn other softwares as well, applications.
Yeah, there are many softwares which are available. OpenCV, the case has been taken up by Dr. Bhavesh. MATLAB is another one, and many more licensed softwares are there. OpenCV is freeware, so that is why we are suggesting that it's a good software, OpenCV, and the students can easily get it without paying anything. And Dr. Bhavesh can also add in case he wants to say something on this.
Of course.
You are muted, Dr. Bhavesh.
Yes, I will like to add upon that is, see, we are offering that is basically image processing with machine learning and deep learning. Okay, so maybe nowadays everybody is aware of AI, machine learning and deep learning, artificial intelligence, and this thing. So there are lot many functionalities which are actually going parallel with images, because images, even the latest system, the deep learning system or the machine learning system, they will be working on the basic images. So you need basically the basic understanding of the images, how you can operate on it, as well you need machine learning and deep learning. So we do have actually multiple number of cases, courses which are handling them. So that way you can say, if I go for deep learning and computer vision using that, that will be basically there are many versions of Python, that is TensorFlow module is there, or maybe Colab is there, or maybe CodeLab is there. Okay, there are many from IBM, from Intel. Everybody are providing their own cloud platforms, and accordingly that sort of functionalities will be added. Okay, one more area specifically that it will be, that is implementing this sort of image processing and machine learning or deep learning algorithm on hardware system. Okay, so when you implement them on hardware, that is edge device basically, maybe with IoT and this incorporation of them, that becomes the latest era also, and we deal with that sort of hardware also. So there are lot many hardware starting from Raspberry Pi to many more. Actually TI processors are there as well, many more to come actually, Jetson Nano from Nvidia, or maybe, so there are there actually. So so depending on looking at your orientation, image processing will be combined with some other areas, and that way you can, I think that is
Thank you
answered.
so much. Thank you so much, sir. So thank you, Professor Bhupinder Verma, sir, and thank you, Dr. Bhavesh Kumar, sir, for resolving all the queries from our attendees. And attendees, you have heard our mentorship. So if you want to gain all these expertise, you have to come to the university, take admission in School of Electronics and Electrical Engineering, and gain this expertise and make a better career over here. So thank you so much, sir. And for all the admission part of the university, we have our expert, Ms. Rachna Bajaj, Senior Assistant from the Division of Admission. So ma'am, over to you for the admission part of the university.
Thank you so much, Dr. Ruby. I'll just quickly share some important details with our students that how they can apply for admissions at LPU and what are some of the important dates. So what you have to do is just simply visit our website, which is www.lpu.in. And on the top, you will see an icon of admissions where we have segregated all the programs, like be it after 12th diploma programs, after 12th graduation programs, or after graduation if you want to proceed for masters, or after post graduation if you want to enroll yourself for doctorate level programs. So let's say I'm interested in after 12th programs. I'll click on this icon and all the programs, be it related to engineering, computer applications, IT, will be available right in front of you. So I'll just click on engineering, and here we have segregated all the streams which are available at LPU, be it related to electronics and communication engineering, electrical and electronics engineering, etc. So let's say I'll pick up electrical and electronics engineering, and you will get to see all the important details, like be it related to duration. The duration of this program is 4 years with total 8 semesters, and the eligibility criteria clearly states that a student should have minimum 60% in 12th with physics, maths, and English as compulsory subjects. And the student also need to qualify JEE main or LPU NEST exam, which is conducted by LPU. So this exam is stated as National Entrance and Scholarship Test. So this exam will not only help you enroll yourself for the eligibility, but also avail better scholarships. Moving ahead, you can see some of the placements, as sir has already shared the rankings, the curriculum for next 4 years, be it related to the electives, the language electives, pathways, open minors, whatever are being offered in this program. Moving ahead, here comes the most important part, I suppose, the monetary aspect. Although the without scholarship fees for this program goes 1,20,000 per semester, but we have several scholarships students can avail for. Let's say if you score 85 to 90 percentile in your JEE, or if you score between 80 to 89.9% in your 12th, you will directly fall in category 3, that is of 28%, and your fees will be reduced to 86,400 per semester. Let's say if you score better, if you score 90 to 95 percentile in your JEE main, or if you score 90 to 94.9% in your 12th, you will directly fall in category 2, that is of 38%, and your fees will be reduced to 74,400 per semester. Last but not the least, if you score 95 or above in your JEE main, or if you score 95% or above in your 12th, you will fall in category 1, that is of 48%, and your fees will be reduced to 62,400 per semester. Apart this, if you couldn't score well in these categories, we also have the LPU NEST exam. It will be for 400 marks, and this is the tentative cutoff we have mentioned to fall in category 3, 2, and 1 scholarship simultaneously. Moving ahead, we have listed some other scholarships as well. Other special scholarships include scholarship based on innovation, startup, and entrepreneurship. Special scholarship for toppers of education board falling in the merit list of 2022. So if you have any such achievement, share your details with us on our email ID, which is admissions@lpu.co.in. We also have some financial aid for need-based, which covers scholarship for single girl child or single mothers, etc. Financial aid to retired, serving defense, CAPF, paramilitary, financial aid to orphans, and financial aid to person with certain disabilities. So you can share this information with the near ones if they want to enroll themselves in this program. Moving ahead, I'll wind up with some important dates. As you can see that the last date to take admission in this program with this maximum scholarship benefit is 31st July. So hurry up. Today is already 28th July. Enroll yourself for the entrance test, and accordingly you will get exam dates between 6th June to 5th of August. And within 24 working hours, your result will be declared. and accordingly you can proceed for admission. In case if you have any queries, feel free to get in touch with us. On the right side of the screen, we have listed our live video counseling icon, our schedule a call icon, our WhatsApp team is there for you. And once you scroll here, you can see our helpline numbers as well. And with one more important thing, I'll wind up. We have already conducted such informative webinars in the past, and we will be keep conducting such webinars in the coming days. So if you want to go through such details, again, just click on admissions. And on the left side, you can see an icon of LPU's Edu-Fair webinars. So over to you, Dr. Ruby. I hope I have shared some important details with our students, which can be helpful for them to apply for admissions at LPU. Thank you so much.
Thank you so much, ma'am, for the detailed information of the admission part. And I believe attendees, they have got all the information how to route towards the website, how to take the admissions, how to check the eligibility. And attendees, I must tell you, I suggest you that decisions determine destiny. To decide your own date and take the admissions as soon as possible. So thank you so much, sir. With this, we conclude today's webinar. Thank you, attendees, for spending time and participating in today's webinar. We appreciate you all for being here, and I believe your knowledge has been enriched by the information provided by your experts. So also, I would like to express my appreciation to the experts for their valuable contribution on this webinar. I'm sure your years of experience, your years of research will definitely help the attendees to take the right path. So until next time, I, Ruby, will finally sign off the session. Thank you, everyone.
Yes, Ruby, can I add two things, if you
Yes,
allow?
of course, of course.
Just somebody was asking about the areas of image processing. So I would just answer that the work here going on is in, suppose, one area that is medical imaging, right? So you may have work on X-ray images, CT scan images, or MRI images, or Doppler images is one area. Satellite images, that is another area altogether, right? And normal images, that is again altogether. There are new types of images, that is microbiology images. So lot many horizons are increasing for the image processing. And so welcome all of you. Thank you very much. Yeah.
So you were discussing, there was another query from Geeta Gujari. She wants to know that does open source provide all the features as commercial ones?
See, nowadays actually the things have started reversing basically. Yes, this is a quite interesting comment. There is a lot of debate initially was happening. See, suppose if I go for deep learning in MATLAB, it is bit backward and there is no that much support available. Functionalities are also bit reduced. Compared to it, open source community has started advancing so much that specifically in the area of machine learning and deep learning, it has so much support or so much advancement that is means it could be almost unbeatable, at least currently. Okay, of course sometimes many old software it was finding that the open source will not efficiently work, but this is not the case now the open source community is too large and too much aware, too much giving their hard work, and that's how it is even not just equivalent, it is going beyond what even the private can assure, right? Maybe it Wikipedia source, or maybe you can say this sort of Linux platform, or maybe it is Python, or for specifically deep learning and machine learning.
Thank you so much, sir. So that's all for today's attendees. These kind of information webinars are more on the way. So stay tuned with us. Today, I will take the leave. So thank you so much, sir. Thank you
Thank you so
for
much.
your guidance. Thank you, sir.
Welcome. Thank you.